Carter Smith. I'm going to be doing an exam 2, part 3, question 1 review and explanation of what the correct answer is. This is going over acidity and basicity, and some factors that we have to account for is basically how electrophilic the atom that's donating the proton is for this molecule. For each of the molecules, you have to look at all of these molecules in this problem are going to be ring structures, either ring structures with or without conjugated pi systems, and they all have a nitrogen in them. And so basically, to figure out what atom is the most acidic, you have to look at how resonance is stabilizing the ring, or lack thereof of resonance is destabilizing compared to other structures. You have to look at how the electron distribution of the ring is due to induction, like an electron withdrawing group destabilizes the ring and makes, well, it stabilizes the ring, but makes the hydrogens more acidic. Well, you also have to take into account basically the just whole general structure of the ring and how it's going to affect what acidity or pKa it's going to have. So if we look at all of these ring structures, you can see that I've already ranked them, but it's easiest to go through them if we go through the stability factors, just looking at them. Since there is no formal charge on any of them, you're going to have to look at these as partial charges and how the nitrogen affects the partial charge of these ring systems, because they are the most electronegative atoms in this, other than the oxygen on B, but generally they're the most electronegative atoms in these rings. So if you look at the single ones, you can see that there's going to be more charge associated on this, meaning the hydrogen is more easily donated. But all of the hydrogens are linked to a nitrogen. So that doesn't really change much around there, except for there's B and D, which have a nitrogen attached to the beta position, or I guess that would be meta position. If we're talking about for ring structures, but I guess that's only with 6-membered rings. But either way, point is, this nitrogen right here in this position is also affecting how the electron charge distribution is. It is more of a partial negative there, but generally it is making it a little bit more acidic than ones without the nitrogen there, because it is pulling electrons away from the hydrogen, even if it's not that noticeable since it is a little bit further away and it's only nitrogen, so it's not super electronegative. But either way, it is making it slightly more electronegative than the rings without the nitrogen in that position. So if you're going to look at resonance stabilization, which is a really important factor for all of these, you have to look at the conjugated pi systems, or lack thereof, that they have in these systems. So as you can see, C is the least acidic because it has no conjugated pi systems. There's no resonance stabilization. If this were to pop off and there would to be another negative charge on this nitrogen, then it wouldn't benefit from having a larger pi system in the first place. Whereas if we go a little bit up, A does, because now it has a conjugated pi system of the negative formal charge on the N and this pi bond right here. So then you can also see that as you go up one more time in E. E has the same ability, and D is a little bit more than that, since there's the positive, there's the negative, there's the lone pair on this nitrogen right down here. And then you can also see that kind of in B, but it's pretty much the same thing. And there's the two double bonds on these nitrogens, which are going to show exactly how there's a little bit more of a conjugate pi system I can go through. So then if you're going to go down a little bit more, the only change in hybridization among these is the N at the bottom position in B and D, which is a little bit, makes the ring a little bit more stable since a little bit less stable actually, since it's a lower hybridization than say like an sp3 or something like that. But then a really important factor we're going to go look at is induction, because you can see that B is the most acidic because the O2N group is pulling electrons away from the ring, stabilizing it, making it more easy to donate a proton. So if you can look at all of these factors, you can see that C has almost none of these factors, so it's pretty stable. It's more stable in the state than the other ones are in their state. This would be the least stable in its state since it's pretty stable as a base, having this hydrogen donated. And go down the reverse way. Second least stable, third least stable. Oh no. First most stable, first least stable, second least stable, third least stable, fourth least stable, fifth least stable. So if you can look at these, you can see how all the stabilization factors are affecting exactly how acidic all of these are due to what the stabilization factors are doing for the base versus the acid. So if you're to gain a negative charge on the nitrogens or leaving it in this state, what's more stable? So you can see by the way I ranked that's according to those. So just really have to look at the stabilization factors and what the difference in a base versus an acid is going to